So now we have the beakers all populated, and this is the very first one we did. This is the very first beaker we did, and we can see the salt is still not melted. So we're gonna turn on the ultrasonics and run it for a while. Okay. We can see that on some of the beakers will rotate from the power of the ultrasonics. Depending on how they're sitting and how they're subjected, but they all turn a little bit at least. So obviously when the beaker is turning, it may or may not help in dissolving the salt. We can see the salt moving at the bottom of the beaker. You can actually see it dissolving. now we'll measure the temperature. And the temperature is 82 degrees Fahrenheit. So it's about 80 to 82 degrees Fahrenheit, the temperature. It seems that the second tank we missed to turn on the ultrasonic, so we just turned it on, and I'm going to record the time. There's a 5 minutes difference between them. We have added extra weight to keep the beakers in the liquid. If the proper collar, the Teflon collar, was placed in, no additional weight would be needed. Now if you notice, the beaker with the Teflon collar is turning more, and that's because less weight is applied on the beaker. So if they all had Teflon collars, all the beakers would be rotating in the ultrasonic. So we hope that'll be the case. So as you can see here, the beaker with the Teflon is rotating more than the other ones, and that's because it weighs less. if we were to remove the weight on one of the other ones a little bit, it'll be more prone to rotating. So we recommend that all the beakers would have the white collar and not the black collar, because the white one weighs more, and it's just the perfect weight to have the beakers rotating. It's right on the verge between to start to float at 250 milliliters. Now it's been 10 minutes on those beakers, and I want to lift it up and see what we have. Now this is rock salt, so there's maybe some sand in there. So we're going to try to examine what's left in it that is sand and what's not. But it seems like 95% at ambient temperature is melted. Same with this. You can actually see the solution. This one looks well mixed, but they're more or less all very, very similar. The ultrasonic pressure is 100 watts per square inch here. 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 So the ultrasonic power is the same in both tanks. The only difference is that this has more beakers, and we can see at 10 minutes this tank has dissolved better than this one. These ones look completely dissolved. These ones look completely dissolved. The middle tank is completely dissolved. And these ones are not. So what we saw was the tank that had more flasks, the salt dissolved faster than the tank that had few flasks. And the reason is that because the ultrasonic frequency bounces around on the flasks, causing more energy to be used and less energy to be lost. So the more flasks you have in the tank, the better the mixing is going to be. And that is pretty evident because the ones that we started later have better dissolution of the salt and than the one we started earlier. I measured the ultrasonic pressure in both tanks and they're both the same. So I would conclude here that it is better to have more flasks in a tank than less flasks. So let's look again at the tank that started 5 minutes earlier, and we can still see a little bit of salt. We stopped the experiment at 11:05. So I'm gonna write this down. And so we stopped the experiment at 11:05. The one with the 4 beakers still have a little bit of sediment at the bottom, and the beakers that we started 5 minutes later, which is the So this tank started 5 minutes earlier than that tank, and that tank, which has the 20 flasks, which is this one that has 20 flasks, we see that the flasks, as if it was melting better. So we have a little bit more action going on. And this is at ambient temperature. All the salt is dissolved very similarly between the flasks. This one is like completely dissolved. These are completely dissolved here. And the ones at the corner, this one is completely dissolved. This one is also completely dissolved. This one still has some at the bottom. And this one is completely dissolved. This one is also. This one as well. This one has a little bit at the bottom here. So we started the experiment on this at 10:45 and ended at, on the first tank, this tank, we started at 10:45 and stopped it at 11:05. So that's 20 minutes. And this one 15 minutes. We started at 10:50 and ended at 11:05. The most important thing to note here in the experiment that I haven't mentioned yet is that the slower the weir is moving, the better the mixing you're going to have. The weir will slow down your ultrasonic energy. And if you can see now, I turned the weir off, and you can see how much the flasks are turning. They turn more, there's more ultrasonic. So in order to get better mixing, what you need to do is trickle down the weir, the pump, all the way to the minimum. So it's barely moving, the water. The less water activity we have, the better. So I'm going to test the ultrasonic energy now in this flask here. And it's reading about 10 to 15% more power when you turn the weir off. I'm reading now 150. When the weir is turned off, but when the weir was turned on, I was reading 120. So we're talking about 20% or something like that difference. So if I turn the filter back on, okay, now the weir is back on. I'm going to slow the motion. Now watch the weir action here. That is too much. You need a lot less water flowing. See the water flowing here on the edge? That's too much water. So I'm closing the valve down. This is the valve. And I'm gonna close it down until it barely flows. So now I choke the water down. It's barely dripping now. So I'm going to test the ultrasonic energy again. You can leave it on. Now with the water completely turned off, I was reading about 120 or 115, and or no, if it was completely off, I was reading 150, and now I'm reading about 145 and even 150. So we can run the ultrasonic and the weir at very low level weir flow and still have a very good ultrasonic power. And this is considered very good. So the important thing to note is to slow down the pump. When you slow down the pump, you increase the ultrasonic by about 20%, and that makes a big difference on mixing. So we just turned it on after we slowed the pump down, and we can see now that it does help, because now these flasks look a lot cleaner than before. So the smaller the pumps you have, the better the mixing. That's why we picked those small pumps, but the flow was still too high. So this is with an open valve, and that gives you low power ultrasonic. And this, when you close it nearly all the way down, you get a lot better mixing. So this is very, very important. So just a couple of minutes with the higher power made a big difference. So see a little bit here. So that should conclude the ambient test.